Today we're going to talk about compound inequalities. By definition, compound inequalities are two inequalities that are joined together by the word and or. Now sometimes you may not actually see the word and or, but it's all about how the problem is written. For example, if I was to give you 3 is less than 2x minus 1 is less than 11. Believe it or not, this is actually two inequalities. This is 3 is less than 2x minus 1, and 2x minus 1 is less than 11. Now, when I solve it, I'm not going to break it up like this, but this is just to show you how this is an example of what is called a compound inequality. Now, just like before, our ultimate goal is to get the variable by itself, to isolate the variable, to get the variable, in this case, between the two inequalities. So we're going to solve this problem. 3 is less than 2x minus 1 is less than 11. I'm going to start by adding 1 to both sides, just like you would do to a normal equation or inequality. So when you add 1 to all sides, you're left with 4 is less than 2x is less than 12. Now remember, our ultimate goal is to get the x isolated in between the two inequalities. So the next thing I'm going to do is divide everything by 2. And when I divide everything by 2, I'm going to be left with 2 is less than x is less than 6. Or x is greater than 2 and less than 6. When I read it, I'm actually going to start reading it from the center. X is greater than 2 and less than 6, which basically just means that x is somewhere between 2 and 6. So if I was to graph this on a number line, and let's say this is 2 and this is 6. If I was to graph this, they're going to be open circles because it's less than. There is no line under the symbol, so there is not going to be a closed circle. So it's an open circle over 2 and 6, and I shade in between them, symbolizing that the answer is going to be somewhere between 2 and 6. It can't be 2, it can't be 6, it has to be between 2 and 6. It can be 2.1, it can be 2.0001, but it can't be 2. Let's actually try this again. Let's try this again with a different example. This time we say negative 7x is less than or equal to 3x minus 4 is less than or equal to 5. Negative 7x is less than or equal to 3x minus 4 is less than or equal to 5. So this time I'm going to give you negative 7 is less than 3x minus 4 is less than or equal to 5. In fact, let's make that a less than or equal to 2. So we have negative 7 is less than or equal to 3x minus 4 is less than or equal to 5. The process starts the same. We start in the center, and we're going to add 4 to all sides. When I add 4, I'm left with negative 7 plus 4, which is negative 3, is less than or equal to 3x is less than or equal to 9. I got to get that x by itself, so I'm going to divide all sides by 3. When I divide by 3, I'm left with negative 1 is less than or equal to x is less than or equal to 3. And remember, when I graph this on a number line, this time make sure you notice that there are lines under the symbols, so that means that when I graph it, it's not going to be an open circle, but it's going to be a closed circle. So I put a closed circle on 1, and I put a closed circle on 3, and this is an and problem, so I shade in between the two. I shade in between the two. Now we're going to try it one more time in a problem that's not an and problem. So if I gave you, let's see, delete that. 4x minus 8 is greater than or equal to negative 12, or 6x plus 4 is less than negative 20. Here we have an or problem, a problem that's divided. It's already separated for you, so it's pretty easy to be solved. So I'm going to solve them separate. Treat them like they're two separate problems. We have 4x is greater than or equal to negative 4. Divide both sides by 4. And x is greater than or equal to negative 1. Or, let's solve this one now. Subtract both sides by 4. Left with 6x is less than negative 24. Divide by 6. And x is less than, what is that? Negative 4. All right, so that means our answer, x, is somewhere between negative 1 and negative 4. It's greater than or equal to negative 1, or it's less than negative 4. It's not in between. I messed up by saying that. But if I graph them, because it's not an and problem, I'm not going to graph in between this time. So here's negative 4 on the number line. Here's negative 1 on the number line. The negative 4 is an open circle because there is no line under that symbol. But negative 1 is a closed circle because there is a line. So watch this. The problem says x is greater than or equal to negative 1. So we know it's either going to go this way because it's greater than or equal to negative 1, or less than or equal to negative 4. So that means when it's an or problem, when you shade, it goes the complete opposite way. It does not go the same direction. Please don't make that mistake. An easy way to remember that is by looking at the signs here. Notice this problem is pointed to the right. The sign is pointed to the right, so that means I shade it to the right. Over here with the negative 4 is pointed to the left, so I shade it to the left. This only works when you have an or problem.